Okay, guys, so I'm going to start recording video 2 of section 15.7, and here in this section I want to, again, in this video, I want to solve two problems with distance, rate, and time application. So again, I just want to recall it that distance, it's rate times time, which is speed times time. So we're going to use that. And you guys have, in your textbook, you have more examples. However, I like to introduce, when I create the lectures, the skill practice. So you have more examples. And again, if you need to read something similar, you have the example in the textbook. Okay, so we're going over skill practice number 5. So let's focus on this one. Okay, so section 15.7, this is video 2. And here we're going to talk about distance, which is equal rate times time. So distance, it's equal rate times time. Okay, with the distance formula, again, you can always solve for rate or you can always solve for time. But this is the formula which, of course, all of us, we need to know, and we use that already in previous problem. So let's read this problem. Alison pedals her kayak in a river. Excuse me, let me just pause the video. Okay, so we're going back. Alison paddled her kayak in a river where the current is 2 miles per hour. So let's just list the important information. She can paddle 20 minutes with the current. In the same amount of time, she can paddle 20 miles with the current. In the same amount of time, she can paddle 10 miles against the current. Find the speed of the kayak in still water. So that's going to be our x. Okay, so again, x is the speed of the kayak in still water. I'm going to create a table, but a couple things about this problem. I want to mention that Alison paddled 20 miles with the current. In the same amount of time, she can paddle 10 miles against the current. So I want you to guys know this very important information, that the time with the current is the same as time without. That's going to be our information without the current. So that's going to be our equation which we're going to set up. Time with the current is equal time without the current. So when we talk about the time, so don't forget that the distance formula is equal rate times time. Okay, so the distance is rate times time. So what we need to do, you need to use this formula and solve for time. So to solve for t, we're just going to isolate t, so divide both sides by r. Okay, so we know that time, it's equal d over r. And again, don't forget that we're going to use the information that time with the current, okay, is the same as time without the current. okay, and time is just distance over rate. Okay, so those two, they will go together. Okay, now let's put all the information in the table. So we're talking about the distance using distance formula. So distance, it's rate times time, and we have two situations here. Okay, we're talking about Allison pedal with the current. So the first row will represents the situation with the current. The second row of my table will represent the situation when Addison pedal against the current. Okay, so let's start fill up the information. So first of all, don't forget that x represents the speed of the kayak, which is the rate. So with the current or without the current, of course, we're going to have a speed of the kayak. Okay. Now, with the current, that means our speed will be faster. Against the current, that means our speed will be slower. So let's go back to that problem. Alison paddled her kayak in a river where the current is 2 miles per hour. Okay, so the speed of the river of the current is 2 miles per hour. So when we talk about rate, which is technically speed, in that situation with the current will help us, so our rate will be faster. So we're going to take the speed of the kayak plus the speed of the current. Okay. Now, when we talk about situation against the current, okay, so the speed of the kayak is x. However, we pedal against the current, which means our speed decrease. So we're going to subtract 2 from the speed of the kayak. Again, 2, it's the speed of the current. Okay. So now she can paddle 20 miles with the current. So that's going to be a distance with the current. And in the same amount of time, she can paddle 10 miles against the current. Okay, so now here the equation will be the time with the current, it's equal time without the current. So I use that information right here. They're saying that she can paddle 20 miles with the current. In the same amount of time, she can paddle 10 miles against the current. So we know that we're talking about the same time with the current and paddle back against the current. So again, time, to calculate the time, I use the formula of the distance. I rearrange that formula and I know the time, it's distance over rate. Okay, that's right here. I know the time, it's equal distance over rate. So let's talk about the time with the current. The time with the current will be distance, which is 20. Again, time, it's equal distance over rate. Okay, so time, that's the situation with the current, will be distance, which is 20 miles, over rate, which is x plus 2. And of course, the time against the current is the same. However, when we're using the information from the table, the situation against the current, to calculate the time, it's going to be 10 divided by rate. And the rate of the kayak against the current, it's x minus 2. Okay, so now to solve the problem, we're saying time with the current, it's equal time without the current. Equal time against the current. time with the current is 20 over x plus 2 equal time against the current, it's 10 over x minus 2. Okay, so what we're going to do, we're going to solve proportion because you have ratio equal ratio, which is proportion. So solve it using cross multiplication. All the time when you have fraction equal fraction. Okay, so I multiply across. So that will give us 20. And again, let's just put those expressions in the parenthesis. 20 times x minus 2 is the same as 10 times x plus 2. Okay, and we're going to distribute 20 to both. So we end up with 20x minus 40. It's equal to 10x plus 20. And solve for x. I'm subtracting 10x from both sides. And we're getting 10x minus 40 equal 20. And just add 40 to both sides. And we're getting 10x equals 60. Divide by 10. Divide by 10. And we're getting that x is equal 6. Okay, x is equal 6. So going back to the problem, x represents the speed of the kayak in still water. So 16 miles per hour is the speed of the kayak in the still water. So answer, the speed of a kayak in still water is 6 miles per hour. Okay, so that's the speed of the kayak in the still water. And again, with the current that will be 8, without the current that will be 4. Okay, and I have one more problem. Also application of distance formula. So one more. Okay, and this is example 6. And I'm using our textbook, page 945. Okay, so let's go back. Let me copy that problem so it will be faster. If you can see it, page 945. And I'm using Harley. Okay, and this is skill practice 6. Okay. Okay, so this is number 6. I'm sorry, skill practice 6. We have Harley rode his mountain bike 12 miles to the top of the mountain and the same distance back down. So here we're going to use the information that distance is equal. Okay. His speed going up was 8 miles per hour slower than coming down. The ride up took 2 hours longer than the ride coming down. Find the speed in each direction. Okay, so this is what we need to find, speed in each direction. Okay. So again, since we're talking about two directions, so let me say x is going to be speed to the top of the mountain. Let's see. Let's read this information. His mountain bike 12 miles to the top of the mountain and the same distance back down. His speed going up was 8 miles per hour slower than the coming down. Since I comparing speed up to the speed coming down, so it's better to express the x to be speed coming back, of coming back, of coming down. Let's say it that way. Speed of coming down. Okay, so still this is the problem where we're going to use the application of distance formula, which is rate times time. Many times we need to modify that. So since we're talking about the distance, I'm going to start create my table. It's just easier for me to keep the most important information. So distance, rate, time, and we have two situations. We're talking about trip to the top and then trip back. Okay, so let's start putting the most important information. So Harley rode his mountain bike 12 miles to the top of the mountain. Okay, so we know the distance. So 12 miles to the top of the mountain and the same distance back. So what we're going to do, we're going to put 12 here and 12 here. Okay, we have the same distance. His speed going up was 8 miles slower than coming down. So again, speed of coming down, that's my x, okay? And his speed going up was 8 miles slower than coming down. So that's going to be x minus 8, okay? And we don't know too much about the time, but don't forget that when you guys solving those problems, you want to only introduce one variable, okay? So look what happened here. They're saying that the ride up took 2 hours longer than the ride coming down. So I know the difference of time, okay? The ride up took 2 hours longer than the ride coming down. So how am I going to translate that? Okay, that information. Okay, ride coming up. Okay, so here I'm talking about time of trip to the top minus time of trip coming back. Camping, I'm thinking about camping. Coming back it's equal to. Okay, so I'm using that information that the ride up took 2 hours longer than the ride coming down. So that means the difference between those two times, it's 2. Okay, and that's actually, it's going to be the equation which I will use to solve this problem. Okay, so I'm going to use that equation, okay, to solve the problem. Since I don't want to introduce the new variable for time of the trip to the top and trip coming back, so what I'm going to do, okay, we did that before, but I'm going to use the distance formula and I'm going to solve it for t. So I'm going to solve for time. So to get time, we just need to divide each by r. So I know the time, it's equal distance over rate. Okay, so time is distance over rate. So time of the trip to the top minus time of the trip coming back, it's equal to. So let me figure out what is the time of the trip. Again, time is distance over rate. So I need to figure out what is the time of the trip to the top. So that will be the distance over rate, which is my speed, x minus 8. Now, time of trip coming back, so time, the formula is distance, which is 12, over rate, rate is x. Okay, so time it's not equal in this case, so you cannot say that 12 over x minus 8 is equal to 12 over x. No, we know that the difference between those two times it's 2, okay, 2 hours. So let's just rewrite it. Time of the trip to the top minus time of the trip coming back equal to. So the trip coming back was shorter. Okay. So time of trip to the top, it's 12 over x minus 8 minus time of the trip coming back, which is 12 over x equal to. Okay. So I'm using that information and then I will be able to figure out what is the speed, which is x. Okay. And that's what I wanted. Okay. So how are we going to solve it? So this is not proportion, okay? Here to be able to solve it, this is rational equation. This is rational equation. So you can't use the cross multiplication. You need to get common denominator, okay? So first to solve it, so step 1 was factor denominators. So I'm just reviewing that detail for you guys because I know we have a test tomorrow. So denominator is x minus 8. It's prime, so it's just going to be x minus 8. And the other one x, so you're just going to keep x since they are prime. Step 2, find least common divisor of x minus 8 and x. So your least common divisor, it's going to be, you have to multiply them. So it's going to be x times x minus 8, since they don't have common factors, so you just multiply them. Okay, step 3, multiply both sides by LCD. And step 4, it's solved. So LCD is x times x minus 8 times the left side of the equation, which is 12 over x minus 8 minus 12 times x, 12 over x equal, so multiply both sides by LCD, so LCD, which is x times x minus 8 times the right side, which is 2. And now step 4, it's solved. Solve for x. Okay, so what we're going to do, okay, don't distribute anything. So what we're going to do, you guys going to treat that as a one expression and multiply that by numerator of each fraction. So that will be x times x minus 8 times 12 over x minus 8 minus x times x minus 8 times 12 over x equal 2x times x minus 8. So here we're going to distribute that in a second. Here we see that x minus 8 will cancel, and here x will cancel. So to simplify that, we're getting 12x minus 12 times x minus 8. It's equal, again, 2x times x, which is 2x squared. 2x times negative 8, that will give us negative 16x. So here we'll distribute negative 12 to both. So we're having 12x minus 12x plus 12 times 8, which is 96, equal 2x squared minus 16x. So 12x and negative 12x cancel, and we end up with 96. It's equal to x squared minus 16x. So this is quadratic equation. To solve the quadratic equation, you have to have a 0 on one side. So I will subtract 96. And we'll end up with 2x squared minus 16x minus 96 equals 0. To solve this one, you need to factor using factor method. What I recommended, okay, find GCF, greatest common factor. So you have 2, 16, and 96. So GCF definitely is equal to. So I'm going to factor out 2. So 2 times x squared, negative 16 divided by 2 will give you negative 8x, negative 96 divided by 2, that will give us negative 48 equals 0. And to not worry about 2, now divide both sides by 2. So I reduce this quadratic equation. Okay, so we end up with x squared minus 8x minus 48 equals 0 divided by 2, which is 0. And now this is quadratic equation, and you guys know how to solve it. You need to factor using AC method. Okay, so A is equal 1, B is equal negative 8, C is equal negative 48. Okay, so step number 1, multiply A times C. That will give us 1 times negative 48, which is negative 48. Next, find two numbers which by multiplication gives you AC, which is negative 48, and the same two numbers which by addition will give you B. So B is equal negative 8. So what's going to work? Negative 12 and positive 4. Negative 12 times 4, it's negative 48, and negative 12 plus 4 will give us negative 8. And now we create factors. Parenthesis times parenthesis equals 0. You're putting x in each. The first factor was negative 12, so you're putting negative 12. The second factor was positive 4, so we're putting plus 4. And now you're just solving two equations. You have x minus 12 equals 0, x plus 4 equals 0. So we're getting x equal 12, x equal negative 4. Again, which one is correct? So let's go back. Don't forget that x is the speed of coming down. So when we're talking about the speed, the negative answer doesn't make sense. So of course we're going to ignore it. Okay, so because it's negative. So x is equal 12 miles per hour. Okay, so 12 miles per hour. Okay, that's the speed of coming back trip. Okay, now if we're talking about the speed going on the top of the mountain, it's going to be x minus 8. So we have 12 as the one answer, and then x minus 8 will be 12 minus 8, which is 4 miles per hour. Okay, and that's of the trip to the top, of the mountain. Again, always solve it. You want to check if your solution makes sense. Yes, it makes sense that the speed of our bike when we're riding on the top of the mountain, it's going to be 4 miles per hour. It's hard. Okay, we have depends of the slope, but coming down, it should be much faster, and we got 12. So it looks like the solution makes sense. So I'm going to stop. So that was 6 problems from section 15.7. You got 2 in this video and the other 4 in the previous video. So section 15.7, it's your last section for test number 4. You're not going to see more new recording. After test 4, what we're going to do, I'm going to set up review problems for you guys for the final exam. And probably I will record 1 or 2 videos when I will go over the review problems of the final exam. And of course, after this video, you're going to see one video when I'm going over the review problems for test number 4. Okay. Stop recording.